Sorry for that interruption. So back to this. When we are doing probability of a sum of 5, that means we need the number of ways to get a sum of 5 divided by the total number of outcomes when 2 dice are rolled. Sorry, that's a lot going on for one little fraction. Okay, so the probability of getting a sum of 5, that's a U, would be the number of ways to get a 5. Well, we wrote them out there. There's 4 ways to get a 5. So what's the total number of options when 2 dice are rolled? Well, we have 6 and 6, so when we multiply those, we would get 36. So there are 36 total outcomes. So 36, which would make this 1/9 if we simplified it. As a decimal, it would be 0.11 or 11%. Let's try that again. What is the probability of a sum of 8? So P sum of 8. So again, I've got my 2 dice. So how many ways can I get 8? So let's start off with a 1. Is there anything I can add to a 1 to get a sum of 8? Well, I could add a 7, but is there a side that says 7 on a dice? No, there's not. So 1 is not going to work. So I'm going to have to step it up. What can I add to 2 to get to 8? Why don't you go ahead and generate this list? 2 plus 6 and 3 plus 5, 4 plus 4, and 5 plus 3, and 6 plus 2. And can I go on to 7? No, I can't, because there's not a side that has 7 on it. So how many ways are there to get a sum of 8? There are 5 ways. So what is the probability of getting a sum of 8? Well, there's 5 ways and 36 outcomes. So nope, that doesn't simplify. 0.139 or 13.9%. Okay, let's move away from dice and now talk about some candy. So if I have a candy jar and it's got 3 green mints in it, 5 red mints in it, 1 cinnamon candy, 3 strawberry candies, and 3 butterscotches, what is the probability that when I choose 1 candy at random, I get a strawberry? So we would write this as P for probability of strawberry. And then we would do success over total. So on this list, how many strawberry candies are there? There's 3. How many total candies are there? 15. So 3 out of 15 would be the probability. 3 divided by 15, okay, those both divide by 3, so we get 1/5, or 0.2, or 20%, depending on how we want that written. Strawberry or cinnamon. Okay, now that word or showed up again. So what does or mean in probability? Or means we need to add. Okay, so what is the probability of getting a strawberry or a cinnamon That means we need to do probability of a strawberry plus probability of a cinnamon. So probability of a strawberry we already learned was 3/15. Probability of a cinnamon, there's only one cinnamon candy, so 1/15. So when I add those, I would get 4/15. And that doesn't simplify, so that would be my fraction. As a decimal, it'd be 0.267, and as a percent, 26.7%. Now, something a little bit different. When I choose two candies, what is the probability that I get strawberry and cinnamon? Now notice, aren't these very, very similar? What's the only difference between this one where it says strawberry and cinnamon and this one where it says strawberry or cinnamon? Note the word in between them. This one said or. Or means we add. This one says and. And in probability means we multiply the probabilities. Okay, now I know that's a little confusing because and is very close to add, so you just have to remember that and does not add, it multiplies. Or adds and multiplies. Because if you're trying to get and, you're trying to get both of them. So, what is the probability that we get a strawberry and a cinnamon? Well, it would be the probability of a strawberry, and since we had that word and, times the probability of a cinnamon. So from our previous thing, we learned that strawberry has a 3 out of 15 chance and cinnamon has a 1 out of 15 chance. So when we multiply fractions, we multiply straight across. 3 times 1 is 3. 15 times 15 is 225. Then we simplify that, and it simplifies to 1/75th, which we can write as a decimal of 0.13 or 1.3%. Last little bit here is geometric probability. On geometric probability, we need to use some area. We need to use the area. So when we use area, we're going to need to know the formulas for area. So for a circle, we have pi r squared. For a rectangle, we have length times width. And for a triangle, we have 1/2 times base times height. So to do geometric probability, we get the probability that we are going to land in our space A. And how we do that is we get the area of A and divide it by the total area. So on this first example, we have a batter's strike zone is 17 by 22 inches. In order to throw a strike that is high and inside, the pitcher must hit a 4-inch by 6-inch zone. What is the probability that a strike will be high and inside? Well, for me, it's going to help me to draw a picture. So if I draw a strike zone here, here's my total strike zone. I know that it's 22 inches tall and 17 inches wide. In order for it to be high and inside, it would need to hit a little area, a smaller area, that is 6 inches tall by 4 inches wide. So it would need to hit this chunk in here, not any of this stuff out here. So to get the probability, pardon me, to get the probability of high and inside, I need to do the area of the 4 by 6 zone divided by the area of the total zone, which is the entire strike zone. Okay, so we would have 4 by 6, which is your inside, high and inside, And then in the denominator, we would have total, which is 22 times 17. So when I multiply these, I would get 24 over 374. Those are both even, so they at least divide by 2. 24 divided by 187. I don't think those divide anymore. So if I write this would be my fraction, or 0.064, or 6.4%. So there's a 6.4% chance that a strike would be high and inside. Last thing, we have a target that's painted as shown. So here's the bullseye, and this inside circle has a diameter of 2 inches. This next circle has a diameter of 8 inches, and this next circle has a diameter of 14 inches. So we're going to do a couple things with this. First, we're going to do figuring out the probability that we would hit the bullseye. So what area would be our success? Well, the area that would be the success is just the blue or small circle. And the entire would be the area of the large circle. So our blue circle, in order to do area of a circle, we need to use pi r squared. Now this right here tells me the whole distance across the circle. Is that the radius? Hopefully you remember from geometry that the radius only goes from the inside of the circle to the edge, not the whole way across. The whole way across is called the diameter. We need just the radius. So the radius is half of the diameter. So what's the radius for this small circle? It's 1. Yeah. So it will be pi times 1 squared. Then the area of the large circle will be this whole thing. But 14 is the diameter, so I need the radius, which is half of that. So 7. So notice this. When I do 1 squared, I get 1 pi. When I do 7 squared, I get 49 pi. And what do you notice is in the numerator and denominator? That's right, pi is in both places. So I can rewrite this as 1 over 49. Lastly, I want to know what is the probability of getting in the red or pink ring. Okay, this one's a little bit trickier because we need to do area of the red ring divided by total area. Okay, so total area isn't too bad. We know that it is going to be pi times 7 squared. We know that from our last one. But this red ring is a little bit tricky because we can't just do, let's see, the radius here would be 4. We can't just do 4 squared because that would include the blue ring as well. And I don't want the blue one, I just want the red one. So what can I do to get just the area of this red ring? Well, I can take the area of the red ring and subtract the area of the blue ring. Okay, so we'll have to do area of the red minus the area of the blue ring. So the red ring has a diameter of 8 inches, so it has a radius of 4 inches. So that will be pi times 4 squared. And then we're going to subtract the area of this blue ring. Oh, and we already know that that's pi times 1 squared. So there I have 16 pi minus 1 pi divided by 49 pi. When we simplify this, we'll get 15 pi divided by 49 pi. And then look what happens again. Your pi's will cancel, and so we will have 15 over 49. Please let us know if you have any questions.